Alright, well, let's examine this problem. It says the graph of the function is shown. Which of the following is true about f? So I'm going to look at all these, and each one of these problems, each one of the answers, has x approaching a or x approaching b. So it seems reasonable to just ignore the answers and just see what happens when the limit as x approaches a. So the limit as x approaches a of this function, let's see what it equals. If we were to approach a from the left, like so, looks like y is getting closer to 4. If we approach a from the right, it looks like it's still approaching 4. So I think it's reasonable to say this is going to be 4. If we examine the limit of f of x as x approaches b, let's see what we get for that. If we approach b from the left, y is getting closer to 4. If we approach from the right, y is getting closer to 1. Since 4 and 1 are not equal, that means that this limit does not exist. So we're looking for an answer that's true. We want an answer that is consistent with this fact and this fact. This says those are equal to each other. 4 does not equal does not exist, so that is not the correct answer. B says as x approaches a, y is approaching 4, which is what we're saying here. So we're pretty confident this is going to be the answer, but let's check all of them, make sure we didn't make a mistake. Y approaches 4 as x approaches b, false. Y approaches 1 as x approaches b, false. The limit of f of x does not exist as x approaches a, that is false. We can confidently say that the answer is only D. Number 2, the figure below shows the graph of the function f with a domain where x is between and including 0 and 4. Which of the following are true? So 1 says the limit of f of x exists if x approaches 2 from the left. Well, let's look at that. X is approaching 2 from the left. Y is getting closer to this value here, whatever that is. So it does exist. So that's true. Second statement. If you approach 2 from the right, the limit also exists. Well, let's approach 2 from the right. The y value is getting closer and closer to whatever this number is here. We don't know because there's no scale on the y-axis, but certainly it's getting closer to something, so that's true. Final part, the two-sided limit exists. Well, that's false, and to be clear, that is false because as you approach 2 from the left, that number is bigger, it's higher than if you approach from the right. For the two-sided limit to exist, it has to be the same number. So we can say that the answer is C, only answer 1 and 2 are true. If the greatest integer not greater than x represents the greatest integer that is less than or equal to x, then the limit as x approaches 0 from the left of 2 over the greatest integer that's less than or equal to x equals, well, let's break this down a little bit. This limit of 2 over the greatest integer function could also be thought of as the limit of 2 as x approaches 0 from the left over the limit of the greatest integer function as x approaches 0 from the left. So this top answer is obviously just going to be 2, because if we were to graph 2, this is, once again, this is y equals 2, that's a horizontal line, like so. Every y value is 2, so no matter where you're approaching from, whether it's 0 or anything else, the y value is always 2. Now the denominator is quite a bit different, it's a lot more challenging. You have to know what this function looks like to be able to do this. So if you'll recall, my x and y-axis, let's say we put a 0 into the function. 0 is the greatest integer, not greater than or equal to x. If I put in 0.1, 0.2, whatever I put in all the way up until 1.99999, as soon as I get to 1, then this function jumps up. And it continues. So this would be 1, 1, this is 2, 2. This is a step function. It looks a little something like this. So if I look at this, as I approach 0 from the left, so here's 0 from the left, as I do that, this y value down here is a -1. So that means that this is going to be approaching the denominator is -1. 2 over -1 is -2. Therefore, this is answer A. Consider the function y equals f of x as shown. That's this graph here. Which of the following is true? A. As x approaches 1, y approaches 3. Let's see. As x approaches 1, it looks like to me y is approaching 1. Therefore, this is a false statement. That should be a 1. 2. If you put 1 into the function for x, you should get 1 out for the answer. That's a false statement. If I put 1 in, I'm going to get 3 for the answer. That should be a 3. It's false. You don't have to explain why these are false. It's just easy, if you're doing these problems, I think, to write the correct answer. If the correct answer is not the same as there, obviously it's false. C, f is continuous for all values of x. Continuous means, in the simplest terms, I could trace over this entire graph, lifting up my pencil. That's not happening here. When I get here, it goes up to this point, and it comes back down, and I continue again. So that's false. A lot of falses. The limit, as x approaches 1, of the function is the same as the function evaluated at 1. Well, since we've already done A and B, we know that's false. Because this answer is 1, this is 3, they're different. If you look at your graph, if you're approaching 1 from both sides, it's 1. If you put 1 into the function, it's 3. Good golly, I hope the last one could be true. None of the above. Well, that certainly could be true, since the rest of them were false.